Now we will drive the mathematical model of this system and measure its performance in Matlab. First, we will consider two state variables to completely define this system. I will take Vc, which will be x1, and IL, which will be x2. Now I will apply KVL to this loop. So here Vt is equal VL plus Vc. Now Vt is equal L d IL by dt plus Vc. Vt is equal L x2 bar plus x2. Here dIL by dt is the derivative of x2 IL and Vc is the state variable, so this will be x1. Now x2 bar will be 1 by L Vt minus 1 by L x1. Now I will apply KCL to this node. So here IL is equal IR plus IC. IL is equal Vc by R plus C dVc by dt. Here IR is equal VR by R, but here VR and VC is same, so VR is equal VC can be written. Now x2 is equal 1 by R x1 plus C x1 dash. Here VC was the x1, so x1 dash will be written, and VC is also x1, so x1 will be written here. Now x1 dash is equal 1 by C x2 minus 1 by RC x1. So I got both x1 bar and x1 dash and x2 dash. Now I will take output as IC. So I will take IC is equal Y. Now I will again apply KCL in node 1. So IC is equal minus IR plus IL. IC is equal minus VC by R plus IL. Here VR and VC is equal same, so VR can be written as VC. So Y is equal minus 1 by R x1 plus x2. Now I will give this equation 1 and this equation 2. From 1 and 2 I can write x1 dash x2 dash. This is the derivative of the state vector is equal the A matrix, which is also known as system matrix, is 1 by RC 1 by C minus 1 by L and 0, and state vectors are x1 x2. plus the input matrix will be 0 by 1 by L, and input vectors is Vt. I am considering Vt as input. So how this work? X1, if I multiply x1 into 1 by Rc plus x2 into 1 by C, like this equation 2, we will obtain x1 dash. In the same manner, if I multiply x1 to minus 1 by L and x2 to 0, then I will obtain, and also if Vt into 1 by L, and so all this will make x2 dash. In the same manner, y will be minus 1 by r into, sorry, not into 1, x1, x2 state vectors plus 0 into Vt, which is the input. So how this works? If I multiply x1 into 1 by r in and x2 into 1, just like this equation 3, we will obtain y. So this is not simple matrix multiplication. If I consider R is equal 2 ohms, L is equal 1 Henry, C is equal 0.5 Farad, then what will I obtain? Here A is the state matrix. Here this is A, this is B, this is C, and this is D. Now A will be minus 1, 2, minus 1, 0. B will be 0 and minus 1. C will be minus 1 by 2 and 1, and D will be 0. So by using all this, I will get a transfer function TF, which will give S by S square plus S plus 2 by using Matlab. So if I give input to this system, I will get an output. So how does this work? So transfer function of this system is this, S by S square plus S plus 2, and we have taken input as Vt and output as IC. If I give a step input, which is like this, to this system, I will get a output in the form of this IC current. So what is the step input? Step input is nothing but a DC source or DC voltage or a continuous voltage. If I supply this continuous voltage in this circuit, then what will I get as IC? We know DC voltage has zero frequency, so no current will be passing through here. So this IC will be 0, but not 0. Initially it will have a value because of the charging of the capacitor. So the graph will be like this. I am giving a step input like this, and I will get a output like this. So how this work? When I giving an input, there will be current flowing through here. Half current will go through here and from half from here. So this current will charge the capacitor. So current will be flowing. Current won't be always 0. Current will flow at initial time, so we will get a value. Then when the capacitor is fully charged, there will be no current flowing through here. So IC will be going down. and ultimately it will become 0. So let's see this in the MATLAB. Before going to the MATLAB, I want to mention one thing first. If our input is sinusoidal like this, then this time we'll get output like this too. Why is that? Because the source is AC signal and here we have an inductor. Some AC signal will be blocked by this inductor and some will move through. Here a portion will be go through this resistor and the portion will be go through this capacitor. We know AC current can pass through capacitor by charging and discharging method. So we'll get a sinusoidal in the response. So what will be the actual response? If our main wave is like this, the response will be like this. Why is that? Because some signal is blocked by this inductor. Let's see this in the MATLAB. Here I have already written all the codes. Let me explain all the lines one by one. First, CLC and clear all will clear our workspace every time we run the program. A is the system matrix, B is the input matrix, C is the output matrix, and D will be 0 because we have not found any value at D. Then from this function SS to TF we input A, B, C, D, and this value will be stored in num and then variables. From num and then we will be changing this into a transfer function model and store it into the system sys variable. Then we have taken t from 0 to 25 second and there will be increment of 0.01 second. We have taken a variable u. U contains a sine wave where omega is 1. Here the form is like sine omega t and omega is 1 and t is the time which is previously defined in this variable. Now we have used another function LSIM. LSIM is used for plotting graphs. So the parameters are like, first we input the system function, then we write the input, and then we write how much time I want to see this graph. And all this I will be storing into V. I will be using subplot of 1 into 2 order, and in the first I will be giving step input to the system. Here a graph will be plotted. In the next I will be plotting the V versus T graph. Here V is the LSIM, the response to the sine wave, and T is the time. Plot parameters are, first we take variables in x-axis and next we take variable in the y-axis. Then I will be holding on to the graph. This plot won't be vanishing. Then in the same figure I will be plotting u versus t, where u is the reference sine wave and t is the time. Then I will be taking another figure where I will be showing you the PZ map, which means where the poles and zeros of the system are located. So let's now run this. First I want to show you that this is the transfer function, and for the figures, this is the figure of the response to the step input. As I explained you before, it will have an initial amplitude and then over time it will be 0. Here the capacitor is charging and when it is fully charged the current will be 0 as time goes by. Here we can see in 12 seconds the current will be 0. As for the next figure, we have taken input. Here the red line shows the reference sine wave and the blue line shows the system response. Here the response is lower than the reference because the inductor already blocked some of the reference input. So we'll get like this. As for the pole and zeros, here we can see there are two poles in the system and one zeros. Because the denominator has second degree polynomial, so there is two poles, and numerator has only s, so the zero zero is in the origin. So what is mean by this pole zero map? So the poles here are left side to the imaginary axis. So if this happens, then the system will be stable. Means for every bounded input, we will get a bounded output. If these poles are left right side to the imaginary axis, the system would have been unstable. Here from this graph, you can see that the system was bounded all the time. Also here the system has bounded outputs and also bounded inputs. So this is all. I have shown you how to analyze a system in Matlab and check its performance. This is an LTI system and we have just seen time response analysis. So that's all. If you have any doubts, please write it to the comments. Thank you very much.